question 37. All right, from the homework, we're asked to essentially calculate the de Broglie wavelength for a proton. And the de Broglie wavelength equals Planck's constant. It's a little bit different. Divided by the mass times the velocity of that object. We do have to use different units on Planck's constant in this case because we're dealing with mass in kilograms. So we have to use 6.626 e to the negative 34. We have to replace joules with like kilograms, meters squared or something like that. I have to look up the units. Yeah, milligram or meters squared times kilograms over seconds, only because we're using mass and velocity, right? So we have to get rid of units of joules and replace that with meters squared times kilograms. So what is the wavelength of this object? So 6.626 e to the negative 34 meters squared times kilograms per second over right, the mass is, they tell us the mass in the equation in the question is 1.673 e to the negative 27 kilograms, and my velocity, it's moving nearly the speed of light, 2.9 e to the 8 meters per second. All right, so multiply and divide to get our wavelength, our de Broglie wavelength of this. So 6.626 negative 34 divided by 1.673 to the negative 27 times speed 2.9 to the 8th. And I messed something up because I got a giant number. Let me see, enter. Something off my formatting. Let me just type it in again. So 1.673 negative 27. Anyone want to go talk to any high school seniors and tell them don't make the wrong life choices, don't go to college. Yeah, go to a trade school. It's not worth it. I wouldn't go. Did it just reach a new all-time high? 2.9 second e to the 8. All right, this will get us closer to a real number. 4.8517 e to the negative 19 over 6.626 e to the negative 34. I don't know what I messed up the first time through that. Yeah, but now we've got closer to where we should be. So now I get a wavelength of about 1.36, 1.37 e to the negative 15 meters. All right, so looking at that question, yeah, so like choice C for question 37 looks to be the closest. The only catch is that for the de Broglie wavelength, it's based on mass and velocity. So we're talking about mass in kilograms, velocity of that proton. And then because of that, we just had to change the units of Planck's constant from joules per second to meters squared times kilograms. It doesn't change the value of Planck's constant, but that just gets rid of, that allows us to cancel out kilograms and end up with the right units of wavelength in meters. All right, so that was like the last thing I think we talked about for module 6 was Oh, Heisenberg's uncertainty principle, but yeah, the de Broglie wavelength too. That matter can have a wavelength. So things at the subatomic level, like electrons do have a wavelength associated with them.